Hello everyone, welcome back to JDCodebase. In today's video, we are solving another super important problem from our LeetCode series, that is the majority element and LeetCode number 169. So this is a very popular interview question and also help you understand pattern like frequency counting and optimize voting algorithm. So let's start. First read the problem statement. Given an array nums of size n, return the majority element. The majority element is the element that appears more than n by 2 times. You may assume that the majority elements always exist in the array. So here if you see in the example number 2, if you see nums array we have given, in the array we have 2 2 1 1 1 2 2. So total here is the 7 elements and 2 is the 4 times and 1 is the 3 time only. So 2 is the majority element because it has the 4 elements and also greater than the n by 2 times. So we have to find out that majority element from the array. So for this problem we have two approaches. First one is the hash map and second one is the special algorithm. Let's first see the hash map code, the how we can solve it. So first let make a frequency map, new map, and in this we store the frequency of every element. Let m is equal to nums.length and start a for loop. Let I equal to 0, I smaller than n and I plus plus. So here in this for loop we count the frequency of every element. Just write a if else and inside this first we check in the else condition we have to write here frequency dot set. Nums of I is the key here because it is unique for everyone, and the frequency first initially it's set to the 1. Then in the if condition, if we already if the frequency map has already this nums of I element, means it is already in the map, so we just check first, extract the value, how much time it is already in the what is the frequency, what is the value of this nums of I element in the frequency map, how much time we seen this element. So for that frequency of frequencies dot get nums of I element, and after that we set again frequency dot set nums of I with the value increased by 1, value plus 1 this time, and also we check if the value plus 1 is greater than n by 2 times, means we see the maximum element, means like here we see the 2 means 4 times here. So is this greater than n by 2 or not? If it is, we just return the nums of I, and also we can set here this here, just previous this yes. So we get the element, and let's run the code here. Yes, it is accepted. Let's try to submit the solution. Okay, it's a edge case. Yes. Oh, I forget to write the edge case because if there is only one element, why we need to store the element into the frequency or map? So for that, if nums.length is equal to 1, then just return the nums of 0th element. There is no need to make a frequency map and all this stuff. Yes, our solution is accepted. So we just store the frequency of each element into the map. In this frequency map, we are storing each element frequency. Here key is the nums of I here nums of I is like 1, 2. These are the unique, and the values are the frequencies. Like we see 1, 1, we see again 1, then its frequency is 2. We see 1 is 3 times, so frequency is 3 here. As soon as any element crosses the n by 2 times, so we return it. Just return nums of I. And this avoid the full traversal at the end, means so we see the element, like there are more elements like 2, 2, 2 more than like here these are the 4 times. So imagine if it is 8 times, so there is no need to check there are the 8 elements or not. Just see there whether the n by 2 cross or not, just return the nums of I. So here time complexity is the big of n. This is very fine for this problem, but the space complexity, if we see, it is also big of n due to the frequency map. Because if imagine if there are the we are storing the key value pairs. So how to optimize this solution? So if you see the input is generated such that majority element will exist in the array, yes. And could you solve the problem in a linear time and in the big of one space? So linear time is the perfect for this, but there is a big of one space complexity not match. We are storing extra frequency. For that we have a optimal solution, that is a Boyer-Moore voting algorithm. This one is a special algorithm for this. In this we just plus and minus this a number. Like if I write here, let imagine I make a index equal to 0. I see the 2, then I increase the value by 1. Then I see the again 2, I increase the value by 1. Then I see the 1. So I just so now it's become 1, it's become 2. Now I see the 1, now decrease the value because this is not equal to 2. So just decrease the value, again 1. So again 1 I get. So again this decrement. Now it's become again the 0, and I again see the 1, so it's become the 1. So right now this one is a majority because I see the 1 is a 3 times. Next I see again the 2, so again I have to minus 1. So 1 minus 0, 1 minus 1, it's 0. Again I see the 2, so now I get the value here is the value is here the 1. So I get the candidate here the 2. Means last element I get here is the 2 element. So this second number. Why? Because if we majority element is like we have an array. We are seeing the means always majority elements come at the end. Whether you are having unlimited time of means many items, whether you have 100 elements, whether you have 10,000 elements, majority element always exists. This question already says always exist in the array, and we have to just track this majority element. Like here if I write the solution, this optimal solution for the big of 1, so for that let count equal to 0, sorry, and then let candidate is equal to null. Right now means here candidate represent the just this one, these elements like 1, 2 or 3, these so start a for loop, let num of nums. I just use the for of loop here, and if count is the value is the 0, I just store the that element here in the candidate equal to that num value, right? Just a simple version. If count and if num is equal to candidate, then we have just increased the count, else we have to just decrease the count, right? And by one again. So in last we know every time we get the candidate means majority element into this candidate. So just let's run the solution. Yes, it is accepted. Let's try to submit the solution. So yes, it's 100% bits and 0 millisecond time complexity, and also the space complexity is the bigger one because we are not using any extra space. These are just bigger one, just normal variables. So here idea is that in this voting Moore algorithm, we are tracking the candidate, we are tracking the element. If it is 0, again replace the candidate. If it is same, count plus plus. If it is not equal, then count minus minus. Means if count becomes 0, pick the new candidate. If same element, count plus plus. If a different element, count minus minus. And majority element will survive at the end, right? So here time complexity again the bigger one. So it's a linear time for traversing a array, and time complexity here is the bigger one. And that is for this problem and for this video. Now you know two ways to solve the majority element problem using a hash map and a super optimized Moore voting algorithm. So if you found this video helpful, don't forget to like the video, subscribe to JDCodebase, and follow along with the full LeetCode series. See you in the next video.